Today you are going to be getting an introduction into geometry, which I think is where all of you are going next year, most likely, unless something happens. So I'm going to go ahead and give you kind of the little intro to it. Today's lesson, and then 11.5 will also be kind of some intro to geometry stuff that I feel like would be really beneficial for you to know prior to entering the class, kind of get you a little bit ahead of the game. So 11.4 is to apply the Pythagorean Theorem and sometimes I write theorem, THM. I don't know if I've really done that for you guys, but and it's Converse. The converse being the reverse of the Pythagorean Theorem. So, let's talk about parts of the triangle, and then we will talk about the theorem. So, this is going to be a right triangle, and typically the book to show you that it will be a right triangle, they will put a red, sometimes blue, but usually a red square in the corner. That's letting you know that that's a right angle. And so then we have here this other side, and I am doing them in different colors for a reason, okay? This side here is what we call the hypotenuse. Apparently this marker doesn't want to write. The hypotenuse, guess you can't really tell that they're different colors, but that's green and this is supposed to be gray. Since that marker's not working, it didn't end up turning out that way. And then this side and this side, we call these the legs, okay, of the triangle. So, just some definitions here. The hypotenuse is the side opposite the right angle. Okay, so hypotenuse, right angle, they are opposites. Okay, right angle, which I probably should have written first, but that's an angle that is 90 degrees. And then the legs are the two sides that form the right angle. Or I should say the two sides that form the right angle. So boom, boom, right angle. So like think about like the corner of your room, that's a right angle, 90 degrees. So that's how I represent that there. Alright, so now that you know the basic parts of a right triangle, I can tell you what the Pythagorean Theorem says. I'm going to write it out in words, but that will be the only time you see me write it out in words, because we will always write it out algebraically. So, the Pythagorean Theorem in words. If a triangle is a right triangle, okay, so this only works for right triangles, then the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. So, I have my right triangle here, side A, side B, and side C. Okay, and C has to be on the hypotenuse, okay, because there's my right angle. Then we say, algebraically, and the way that we will always do it is A squared plus B squared is equal to C squared. Okay? A squared plus B squared is equal to C squared. Side squared plus side squared is equal to hypotenuse squared. Okay? This formula here you have to memorize. Okay, very important. Memorize that formula. Okay? That and the quadratic formula. Those are two formulas you will need to know. And then we will have two more formulas. You'll get in 11.5. Those are four formulas that are pretty much essential to math. Okay? So, remember this forever and always. Don't forget it. And you'll be good to go. Alright, so let's look at some examples of solving for a triangle. And then we will look at the converse in just a minute. Alright, so stuff like 3 through 14 says that, okay, it tells us that A and B are the lengths of the legs of the right triangle and C is the hypotenuse. That's always true. Okay, C will always be the hypotenuse. So C will always be the hypotenuse. A and B will always be the legs. Okay, so that's just information that you need to know. Now, I would recommend, okay, the instructions say to find the unknown length. I would recommend on your paper, every time you start a problem, that you draw the triangle. Okay? I want to start with 8, and then we're going to jump backwards, okay, because I want us to progressively work through this, I should say, and 8 is where I feel like we need to start. So, number 8 tells us that A is equal to 5, and B is equal to 12. Okay? So, I have my A and I have my B. I want to draw my triangle here. It can be just a little small one. Okay, it doesn't have to be anything real big. But I just want to get my lengths on here. Okay, and A and B, it doesn't really matter. I pretty much always will write A on the one going up and down and B on the one going side to side. But it really is irrelevant which one goes where. So 5, 12, and then I want to find C. So I'm just going to write in the letter of what's missing. Okay, so I want to know C is equal to what? And I'm going to fill in that blank with my answer here in a few minutes. Alright, so I'm going to start out, and I'm going to write the formula. A squared plus B squared is equal to C squared. Now, I'm solving for C. Okay, and so here is how to do that, okay? Now, you can plug numbers in initially if you want, and that's fine. Let's just go ahead and do it that way. Alright, so A is 5, so 5 squared plus B is 12, so 12 squared is equal to C squared. 5 squared is 25, plus 12 squared is 144, is equal to C squared. 144 plus 25 is 169, is equal to C squared. Okay. Now, at this point, hopefully this looks familiar from one of the last couple sections that we've covered. with square roots. Hopefully that is something that you recognize. But how do we undo a square root? Hopefully you just said take the square root of both sides. So take the square root of this side and the square root of this side. So C is equal to the square root of 169. You may not recognize that one, but it's 13. Okay, so you're welcome to use a calculator to take the square root if you need to. So C is equal to 13. So I'm going to put 13 up here for C. Now, I'm going to show you, okay, if I were to need to solve for A or B, okay, I'm going to show you what the formulas look like. So, basically, if I need to solve for A, okay, I would have to, let's see. If I wanted to solve for A, okay, A squared plus B squared is equal to C squared. I'd have to subtract B squared. So A squared is equal to C squared minus B squared. And then I take the square root. So A is equal to the square root of C squared minus B squared. Okay? So that formula here is when you need to solve for A. Okay? If I need to solve for B, A squared plus B squared is equal to C squared. Subtract A squared. B squared is equal to C squared minus A squared. Take the square root. B is equal to the square root of C squared minus A squared. So if I need to solve for B, can't hold on to my markers. That's the one you need right there. Okay? Now, you do not have to memorize these, okay? I'm just telling you right now because this is an introduction. Okay, once you get to geometry, you will just have to be able to use these and solve them. Okay, but if I needed to lastly solve for C, this one's easy. Now I'm going to flip it, okay, just for the ease of keeping everything together because I want to solve for C. I'm going to just rewrite this as C squared is equal to A squared plus B squared. Okay, it doesn't matter which order I write them in, if I write the C squared on this side or this side. So solving for C, I just have to take the square root, so C is equal to the square root of A squared plus B squared. Okay, if you can use these, know these, okay, I'm trying to save you some effort while you're solving these problems, okay, and getting used to using the formula. So these should help you significantly when you're doing these homework problems and solving for variables. Okay, I went ahead and plugged the numbers in and then solved for it, which you can do, or you can plug it in straight to this formula. So if I were just to use this formula from the beginning here, so I'm going to do this using the formula that I gave you. So C is equal to the square root of A squared plus B squared. Can't even write. Alright, so A squared was 5 squared, so C is equal to the square root of 5 squared plus 12 squared. So this would have already done it for me, the square root of 25 plus 144, which is the square root of 169. Okay, so then that was equal to 13. So if you want to use the formula, okay, this way it's already solved for you. It's already moving down. Now, the one thing I will say, these two have negative signs in here. That does not square with the v value, okay? It's still this value minus this value. So if that's going to throw you off, don't use these. All right, next problem. So now let's work backwards. So 4. So 4 tells us B is equal to 3 and C is equal to 7, meaning that I want to know what A is equal to. So I'm going to draw my little triangle here. Okay, and I really should put a little box in there just so I know where everything is. So A is what I'm looking for, so I'm writing A there, and then B is 3 and C is 7. So I have my triangle set up. So now I can use this formula let's see, I need the one for a. So a is equal to the square root of c squared minus b squared. So I'm going to use that, okay? Now, obviously, the Pythagorean Theorem says a squared plus b squared is equal to c squared. Okay, so you could go through and solve this out and use this if you want, or you can use the formula that I just wrote out for you. A is equal to the square root of c squared minus b squared, which is equal to the square root of c squared is 7 squared minus b squared is 3 squared. So this is going to be equal to the square root of 7 squared is 49 minus, okay, notice I just wrote that minus sign down, that way I don't get confused. 3 squared is 9. So this is now equal to the square root of 40. Well, what is the square root of 40? I don't know off the top of my head, so I'm going to make a little chart over here. 40 is 20 and 2. 20 is 5 and 4. 4 is 2 and 2. And now, I have a group of 2's here I can pull out, and I have a 5 and a 2 left over. So I can say that a is equal to 2. Square root of 5 times 2 is 10. So a is equal to 2 square root of 10. Okay? Now, your other option, if you don't want to use my formula, okay, this is the last one I'm going to do this for. But the other option is to just start plugging numbers in. So a squared plus 3 squared is equal to 7 squared. Okay, so this is going straight from the formula here. Or let me rephrase. This is going straight from the theorem, not the modified formulas that I gave you. So a squared plus 3 squared is 9 is equal to 7 squared is 49. Now I could subtract the 9, so a squared is equal to 40. And then a is equal to the square root of 40. And then I would have gotten this, a is equal to 2 square root of 10. Okay, so it's up to you which one you want to use. If you want to plug this stuff in and move it over and then solve for it, or if you just want to use the formula that I gave you. I'd say since I gave you the formulas, just use these. That way you don't have to worry about getting something mixed up and moving stuff over. But it's up to you. I'm going to be using this method here going forward. But let's see. Let's do number 10. Yeah, we haven't done that one yet. A is equal to 7 and C is equal to 25. All right. So I need to know what B is. So I'm going to draw my triangle here. Put in my right angle. I know that A is 7, B I don't know, and C is 25. Alright, so I know that a squared plus b squared is equal to c squared, and then I have the formulas already written out. So we want to know what b is. So b is equal to the square root of c squared minus a squared. So now b is equal to the square root of 25 squared minus 7 squared. Now, 25 squared is not something I know off the top of my head, so I'm going to punch it in my calculator. 25 squared is 625. So 625, let's see, 7 squared is 49, so minus 49. And I don't know what that is off the top of my head. Let's see, well, b is equal to the square root of 576, so that's 625 minus 49. Your calculator can do this value for you, okay? Don't sit here and try to, like, pull something out like we did here. Okay, I knew the square root of 40 wasn't a perfect square, which is why I went this route. 576 very well might be. So on your calculator, okay, I realize you don't have this calculator, but you should have a square root button on your calculator. So square root of 576 is 24. So B is equal to 24. So that would be my answer. B is equal to 24. All right, 12 is going to be the last one of this type, and then we'll go look at the converse and do a couple of those. So 12, A is equal to 9, and C is equal to 41. So again, I'm solving for B. I'm going to draw my triangle, drawing my right angle. So A is 9, C is 41, and B we don't know, so we're just going to write that in. Just to get in the habit, A squared plus B squared is equal to C squared. I had already written this formula, so I'm just going to use it here and not pull the other page back over. So B is equal to the square root of C squared minus A squared. Alright, so C squared is 41 squared. So square root of 41 squared minus 9 squared. Now, I don't know what 41 squared is, so I'm going to use my calculator, which you're welcome to do as well. 41 squared is, let's see, 1681. Okay, make sure you don't lose the square root. Minus 9 squared, that's 81. So this is going to end up being the square root of, well, this is nice and easy, 1681 minus 81. Well, that just leaves me with 1600. I'm pretty sure that's going to be a perfect square. Based on the fact that the square root of 16 is 4, okay, and then it's just got some zeros on it. I would assume it's going to be like probably 40 is my guess, but I'm going to check it with my calculator. The square root of 1600 is, yep, 40. Okay, and that makes sense. So B is equal to 40. So then I just write 40 up here. And that's my other value. So that's your intro to that type of problem, but we need to look at the converse of this theorem really quick, and then we'll be done. And I can give you guys some homework. So the converse of the Pythagorean theorem converse of the Pythagorean theorem says if a triangle has side lengths A, B, and C such that A squared, that's what that means such that, I don't know if I've used that before, such that A squared plus B squared is equal to C squared, then the triangle, can't write today, then the triangle is a right triangle. So now we're using the formula to determine if something is a triangle. So, 24. 24 says we have side lengths 9, 12, and 15. Okay, now I should tell you, C is always going to be the biggest side length. Alright. So 9, 12, and 15, so A squared plus B squared is equal to C squared. So in this case, C is 15. So A, we're just going to say A is 9. So 9 squared plus 12 squared is equal to 15 squared. Well, 9 squared I know is 81, plus 12 squared is 144, is equal to, I don't know what 15 squared is off the top of my head, so I'm just going to do it on my calculator. comes out to be 225. So 144 plus 81, I think that's going to give me, pretty sure. This gives me 225, which is equal to 225. So we say that it's a right triangle. Okay, so we showed it, and then we stated that it is a right triangle. Okay, that's all you have to do. So this might be a little bit easier than the first set of problems, honestly. Number 26. 9, 21, and 24. Alright, so again, C is going to be this biggest value here. So A squared plus B squared is equal to C squared, and you should always write this formula out. Okay, for one, it'll help you get in the habit, and for two, it makes it easy to see where you plug stuff in just in case something goes wrong. So we're just going to go in order. So 9 squared plus 21 squared is equal to 24 squared. Alright, well 9 squared is 81 plus 21 squared is, I'm doing these on my calculator since they're really big, 441 is equal to 24 squared is 576. So 441 plus 81 is 522. This right here is not true, so it is not a right triangle. Okay, and you can just write a little triangle symbol if you're needing to write the word triangle. You don't have to like actually write the word out every time. I do that a lot for a shortcut. Alright, and we'll do one last one just to make sure we understand, and then I will give you some homework. 28 is 24, this is a big one, 143 and 145. Alright, so these two are close, but this one is bigger, so that's C. So A squared plus B squared is equal to C squared. 24 squared plus 143 squared is equal to 145 squared. And I'm using my calculator for all these. 24 squared is 576 plus 143 squared is 20,449 is equal to 145 squared is 21,025. So I'm going to add these two together. 20,449 plus 576 is 21,025, which is equal to that. So this is a right triangle. Alright, so hopefully that makes sense. If you have any questions, I know this is like a completely new concept. Okay, it is an intro to geometry, but for all practical purposes, y'all are ready for geometry. Well, yeah, if we were to stop doing work today, I think you guys would be ready for geometry, since I'm assuming that's what most of you guys are taking next year. So, all that being said, your homework for this section is 3 through 11 odd, and 23, 25, and 27. Okay, so this is the solving for A, B, or C. And then this one is right triangle or not. So, the last set of problems we did here. Alright. If you have questions, send them my way so I can try to help you guys as best as possible. I'll be sending out a worksheet video. But if you guys can do these problems, you should be ready to do the worksheets without me really showing you. But just in case, I will try to do a video to help you guys out there.